Alright, day 5. Starting a bit later today because it looked like quite a big problem in the morning just from I opened it and instantly closed it. Alright, let's see again. So you take the boat and find the gardener right where you were told he would be, managing a giant garden. Okay, a water source. Island is the water source. You point out that Snow Island isn't receiving any water. Okay, oh, we had to stop the water because we ran out of sand to filter it with. Okay. Can't make snow with dirty water, don't worry. I'm sure we'll get more sand soon. We only turned off the water a few days. Oh no, his face sinks into a look of horrified realization. I've been so busy making sure everyone else here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? Okay. You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you could help us with our food production problem. The latest Island Almanac. What is this? Alright. Just arrived and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer. So we have relationships here. So soil to seed, fertilizer to soil, and then water to fertilizer. What type of water, right? And so on. Every type of sand, soil, and fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. Alright, nice tip. I feel like if they didn't add this, we would spend a lot of time debugging. Okay, so we have this number of seeds. And we have seed to soil map. I'm not sure. Okay, I can't quite make sense of that. Let's see what it says. The almanac starts by listing the seeds. The rest contains a list of maps describing how to convert numbers from a source category into numbers into a destination category. This is the section that starts with seed to soil map. Yep, that one. Describes how to convert a seed number, the source, to a soil number, to destination. This lets the gardener know. Okay, cool. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers. The destination range starts, the source range starts, the range. Okay, the range length. Okay, so this is the start. This is the start. So seed 50, 51, and 52 could go into 98, 99, 101. Oh, no, sorry, 100. The first line has destination start 50, a source range of 98, and a range length of 2. This means that the source range starts at 98 and contains 2 values, 98 and 99. Okay, not inclusive. Great, 98 and 99. The destination range is the same length, but it starts at 50. So its 2 values are 50 and 51. With this information, you know that seed number 98 corresponds to soil number 50 and that seed number 99 corresponds to soil number 51. Okay, let's read that again. With this information, you know that seed number 98 corresponds to soil 50 and 99 corresponds with 51. Okay, they're going up, yeah. The second line means that the source range starts at 50 and contains 48 values. Okay, you can get quite a few. Got it. Okay. Any source numbers that aren't mapped correspond to the same destination number. Any source numbers that aren't mapped correspond to the same destination number. So the number, seed number 10 corresponds to cell number 10. So, I don't quite understand that last one. Any source numbers that aren't mapped. So the seed number 10 corresponds to cell number 10. Okay, yeah, so seed to soil. Right, there is. Yeah, okay. So, for example, 13 and 14 aren't mapped on here. 79 and 55 are. Okay, so not mapped, not mapped. Okay. Gosh, there are a lot of ranges. Okay, so the entire list looks like this. With this map, you can look up the soil number required for each initial seed. 79 corresponds to 31, 14 to 14, 55 to 57, 13 to 13. Yeah. The gardeners team want to get started as... Oh my god, how long is this puzzle? To get started as soon as possible. So they'd like to know the closest location that needs a seed using these maps. Find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. Alright, let's read that again. Find the lowest location number. Whoa, the gardener and his team. Start again. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. So at the very end, humidity to location. Yes. Find the lowest location number that corresponds to any of the seeds. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. In this example, 79, soil 81, fertilizer 81, water 81, light 74, temperature 74, humidity 78, location 82. My god. Alright. Okay. Alright. This is not too bad. Huge ranges. So part 2 is probably like a caching one. Or like, okay. Alright, so the way I'm thinking is we obviously pass the maps. We do, yep. Pass them. Yep. Are they in order? Seed to soil. Seed to soil, okay, so they haven't been that mean. So, yeah. So, yeah, the thing here, I'm thinking is if you go from 50 to 98, 98 doesn't actually have a number here, right? 98 doesn't have a number, so it would be fertilizer 98. So they don't quite go. But okay, we can have a couple of ranges. I'm kind of thinking what the best way to do this is. So we're gonna have we're not gonna list all the numbers. That's silly. What we're gonna do is we're going to have maybe a mapping, a struct that maps numbers to numbers, right? That is kind of it. You want a function that takes a number and outputs a number. Okay. Okay, let's just get coding. Okay, let's get started. I don't wanna, let's not overthink it. Let's grab the example. And actually I might want to change the way the input is put into here, because I already split it on new lines, and it might be useful to not do that straight away. It might be useful to split it only on those on double single lines. But no, actually it's okay. Let's see. Right, so let's start off with that first line, just seeds, and we're going to remove seeds, this length here, right, to leave us with that. So what we're going to do, seeds equals seeds line equals input what's the length of that? 1, 2, 3, 4, 5, 6, 7. 7 onwards. 7 onwards to input 0 and then 7 onwards to input 0 dot length. Oh, it's a dot dot, isn't it? In Zig. Yeah, there you go. And we're gonna do we're going to do, well, I kind of want to know how many there are, right? So I think I want to split, but then split gives me an iterator, which isn't great. Oh, this type of stuff that yeah, I kind of, yeah, okay, let's just do seed numbers. Let's try standard dot mem dot split. That still returns an so let's just use a tokenized sequence, and we want to returns an iterate that iterates over slice, not the limiter. There you go. And for each one, I want to get the numbers. We're just using an array list, I guess. I didn't want to do this type of stuff where I just use an array list whenever I need, but okay, it's fine. Let's get an iterator. Sorry, an allocator. Standard.mem.pay.heap page allocator var seeds equals array list, and you're gonna be u32 and dot init with an allocator. Yep, awesome. And then for a while, seed numbers dot next, and we need to capture the num. We need to capture num, and we need to do seeds dot append. This needs to be a try. We're gonna append try standard dot fmt dot pass int u32 num base 10. There we go. And we're gonna defer seeds.dinit seeds list, and again I'll do seeds equals seeds list dot to owned slice. I don't really love doing that type of stuff, but it's okay. Seeds number tokenize seed. Oh wait, no, I haven't done this properly, have I? U8, the buffer is seeds line, and there it is. So if we look at the documentation, yeah, buffer and delimiters. Alright, so let's print our slice of seeds. And I can already tell this is going to take forever to do. Oh, yeah, you don't need to try for tokenize. Cannot format an error. Oh, try. Invalid format a string. Oh, come on. Already starting off strong. What is this one about? Oh, Zig format. What actually are you on about? Oh, is this it? I bet it is, isn't it? The rest compiles. Yeah, it was the print, not the rest. Seeds. Let's just do any. Yeah. What was that one about? S4 type U32, I guess. Okay. So is that correct? Yeah. Cool. So we have our seeds. Actually going to write a little function get seeds to, you know, keep things nice and tidy. I thought everything else has been really kind of untidy. So let's take in our input seed line. Actually, let's just take in the entire input so we can do the logic here. And let's delete you and let's return seeds. Var seeds equals get seeds. We need to try that. Delete. Alright, first time making a function, day 5. Great. So we have our seeds and we need to pass the rest. So we need to go one more down. And I'm actually going to keep a counter, an index, which is use size. I'm going to start it at 2 because we are already here. 2, actually 3. Because that's the next line we want to. So we have 1, 2, 3, 4, 5, 6, 7 stops. And what I'm going to have is I think I'm going to have a struct to keep track of these ranges. I'm going to make a struct of these ranges. Struct of these ranges. And then yeah, okay, struct of these ranges, and then yeah, const range equals struct. It has a source start, which is U32. I think you take this, or is it a comma? Might be a comma. Destination start range length U32, and we're probably going to have a function there too. Yeah, we're going to have a pub function compute. It's going to take in an input, which is a U32. I'm really not, you know, these numbers are great. It's going to return a U32. So what it's going to do, oh, it takes in a self as well. Self. Struct fields. God, it's been a while. Struct fields. Struct fields. So yeah, it takes in a self, which is range, or is it star range? Maybe it's just range. Self dot. Okay. If basically we're going to say if you are within our range. So if input is bigger than or equal to self dot source start, and input is smaller than self dot source start plus self dot range. So if we start at 10 and the length is 2, 10 plus 2, 12, smaller than 12 has to be 11. So yeah. So if these are the cases, if this is the case, we're going to do distance from start, which is input minus self dot source start. And we're going to return self dot destination start plus distance from start. And just to really, because I want to get this day right, test range we want, oh, and otherwise we're going to return input. Var range equals range. It's going to take in dot source start. Let's actually use one of their examples. 50 dot destination start. Oh, source. No, that was right. Destination start is 98. Dot range length is 2. Can't expect equals standard dot test dot testing dot expect. We're going to do expect range dot compute of 50 to be equal to, so if we do 50, that maps to 98. If we do 51, that maps to 99. If we do 52, that maps to 52. We can do zig test dot, we can actually go dot slash source dot take 5 zig. Error is ignored. Oh, yeah, because I have to try with expect. Okay, that's great. Let's just do one more check just to be extra sure. Perfect. Look at us. We have some TDD. Well, DTD, development driven testing. DDT. Yeah, sure, something like that. Maybe we won't even get to that part. Anyways, we're on the next one, and now we need to until 4 0 while index is smaller than input dot length. We're going to do var line equals input and the index, and here we're gonna pass it. So it's actually another function, pass range, which takes in a line which is constant weight and returns a range, probably an error in there as well. So here what it does is it grabs an allocator. No, it doesn't. I need var. It does the same as this. We get this. Only that we know it has 3, so maybe not so much need for that. So var source start. Is that what I called it up there? Yeah, source start. Destination start equals, this is equal to seed numbers dot next question mark, and actually we're going to do try standard dot fmt dot pass int straight away. We're going to pass a u32 out of that on 10, and destination start range length. Try, return range, and this is a stack allocation. Stack allocation, even though we need, stack allocation. Yeah, I was wondering because of the function, but in Zig, these get extracted out of the struct, declared, and taken as self. That's why they say self instead of we using the concept of this, I guess. So that's why that's why that works. Alright, we can actually copy line 28. Return range, source start, destination start, range length. Alright, we have some path ranges, so if a line is not equal, line dot length is equal to 0, empty line in between. If we have a redo recess, that means we're here, so we need to go 1, 2 forward. So we say index plus or equal to, and we continue. Otherwise, we do var range equals parse range of our line. We're gonna try, and we're actually gonna print that just to see what it is. Right, we do everything right. Ah, we did not, because we are silly. Oh, invalid character. Did we do the math wrong? Any points? Prints. Any line. Okay, we print one of them. Then we have another line. Just here. It's funny how that. We saw 3, 0, 1, 2, 3. Do the range, but the first one I get is 52. We start at 52. Yeah, we print it as a string. So 52. Oh, weird. Is the index wrong? 0, 1, 2. No. That's so strange. And it does. Oh, why are we? What is this? Alright, let's make sure we have stuff working. So guys, starting at 2, it works. 0, 1, 2. But I don't know why it works. 50. Oh, because I in my input get rid of these. I'm pretty sure. Huh. So I'm gonna do a trick and just check for numbers. Instead, I'm gonna say if line 0 is bigger than or equal to less than 0, or line 0 is bigger than 9, then we continue. And actually we only increased by 1 and continue. Yep, that's right, yeah, because I removed the new lines and I passed the input first. Okay. Let's get rid of you. Actually, no, we can keep those. And it's all good. Let's just double check. 56 on the end, 60, 1, 0. Yeah, that looks all good. Okay. But what we are at is we want some stages. Right, so we're gonna have a first stage, second, well, 0 stage, 1, 2, 3, 4, 5, 6. Yeah, it's kind of dirty way of doing it, but it's okay. What we're gonna do is we're gonna keep an actual array list. No, we're gonna keep an array list. I mean, I guess just because you don't want to deal with buffers and stuff for now. You're gonna do an array list for each one, and then you're gonna set it. Something like that. Alright, so var S to S, soil to soil, wait, seed to soil. Seed to soil is equal to an array list of ranges dot init var allocator equals standard dot heap dot page allocator defer seed to soil dot free, and we're gonna need a couple of these. So seed to soil to fat, because I don't want to type all that. Fat to water to light. What type of light? Sure. Light to temp. We need two more. Light to temp. Temp to humidity. Temp to humid to location. And what we're going to do after is going to just replace var with defer and replace equal dot star with nothing. Actually, let's undo that. Let's go back with semicolon. There we go. Actually, let's do that one more time. Not a semicolon, but not a semicolon, but dot d init. That's it. Okay, that's all good. And here we're going to have an ugly array. If stage to 0, then seed to soil. I mean, could we keep these array lists in like an array list that you kind of have to go through? No, maybe that's complicating it a bit. We can simplify it in a sec. Dot append range. Try. These are declared stages. Yep. Okay. Else if stages is equal to 1, and we're going to take this 2, 3, 4. It's probably right. You. Okay. Seed to soil, soil to fat to water, water to light, light to temp, 1, 2, light to temp, temp to humid, humid to location, 2, 3, 4, 5, 6. And if we ever go through this, we don't just want to increase this, we increase stage plus or equal 1. And just to double make sure, we're going to do seed to soil dot dot size length. Oh, what are they? Append clear the unit allocated to one slice, pop, clone, insert, resize, add one, get last. How do you not? I don't know. What? What are these methods, man? Is there no actually... Wait, is an init? No, we've initted them all. I just want to get the size. That's probably okay then. No. Yeah, that's all fine. Probably. But just to really make sure, because I'm very, very worried about that. Yeah, we're going to do humid to location dot get last. We're going to do an any. And it's a range 56, 93. Okay, good. I believe that's all fine. God, we've taken so long, and when we've just finished parsing. Oh, okay. Next, what do? We do. I think we could make a function that kind of traverses these. So yeah, let me do that, because that's arrays. That actually sounds like something interesting. What I want to do is I want to write var maps, which is an array of array list dot of array lists, and they're going to be seed to soil, soil to fert, fert to water, water to temp, temp to humidity, humidity to there. And what we're going to write is what does the puzzle want us to do? Yep. So we have these. Okay. The second line means that the source range starts at 50. So what they want is for us to get the lowest location from our seeds. So what we're going to write is a function traverse maps, which is going to take a pointer to 1, 2, 3, 4, 5, 6. Let's be precise. Let's make 6. Put this at 6. A pointer to maps. Oh, maps even. That's a pointer to an array of 6 array lists. And array lists, they are expected type. I think we need to say range here. Yeah, I thought so. I thought we have to type the array list. There we are. And this traverse map, what it does is it goes for var iter equals maps dot for. So we traverse. We take the maps, and actually we want an input of u32, and it returns out from u32. So for maps map, what we're going to do is we're going to say input is equal to map dot. Wait, do you not know? Maps dot star. Map dot. Ooh, yeah, we need to, for each one we have to see if it fits. Right, we have to see if there are any which do fit our thing. We need to say, like, if fits, then go. Oh, what if there's conflicts? Because look at this one. Does this one have conflicts? This one does not have conflicts. Do we assume that there are no conflicts? If we assume there's no conflicts, what we're going to write is another function up here. Function fits takes in the range, the inputs u32, and a boolean, and this is getting a bit OOP like. Maybe I don't like it. Return this. And that, and I'm going to change this to be self.fits. Whoa, yuck. Ah, no, it's quite nice code, to be fair. It's fine. Map dot. We're going to go into the first one that does fit, right? And for map dot expect payload m dot it items dot just for item range dot fits if range dot fits input, then we're going to say input is equal to range dot compute inputs. If we do ever reach this, we just say we'll continue with input as the input, but if it does fit into one of these, we want to break out of this loop and go here to get the, well, to continue, right? Yeah, we're just going to return input, and there's no need for the error there. Okay, so any of the seeds, just make sure everything is fine. All right, so what I'm going to now print is /traverse maps, and what I want to take is my maps and seeds 0. Well, how many do we have? We have 4. 1, 2, 3. We're not assigned to constant. Ah, right, yeah, because it's a parameter. Var return mapped value equals inputs. Mapped value returns mapped value. What else do we have? Member function accepted one argument fits. Oh, if self.fits the input. Not promising, right? Because it just returns exactly what they are. So let's just do one. That's 79. So it goes through this map here. Range.fits. I'm gonna print the value the mapped value at each stage. 79, 79, 79, 79. So for that first one, let's take no, 79 should actually. 79 should fit. So let's just do another test here. Range dot fits. Right, this should just be a no-brainer, but that should work. Yeah, so we have mapped value there. We go through the items. We ask if it fits. Print fits. And we're also going to do range dot source start. Oh, never fits. Okay. dot find print self range void just print start destination start length self dot source start self dot destination start self dot range length pretty print and what we're going to do is we're going to do range dot pretty print. Wow, maybe it never reaches this because maps.item is always empty. Map items, that would be always empty. Great. Wait, so this means that these are always empty? What? I could have sworn I tested this. Print size. Maps 0 dot items dot length. Wow, never mind. The very first one ceased to sort, for example. Is it something to do with this not being an array of pointers? And, you know, not taking the address instead? And I guess we could just take in maps now. Because maps is an array of pointers to array lists. Maps dot, and it's going to be maps dot star. Yeah, dot items. All right. Okay. Okay. So that was the issue. The issue was with our inputs. So we traverse. I need to get rid of another print. Oh, the pretty print, yeah. And let's see. Seed number 79 corresponds to 81. That's not right. So we need to fix that. Are we off by one everywhere? No, we are wrong in many places, actually. So that's nice. Okay. So we are wrong in many places. I'm gonna test the 14 because that one seems to be the most wrong. I'm gonna test the 14. I'm gonna print the map value at each stage. So 14, 14. And let's actually take a look at the input. So 14, you're right, doesn't fit here. 14 fits into this one. So the start is 0, so 14 goes to 15 plus 14, 29. Okay. Then we go fertilizer to water to add 29, which we can fit into the second one. So 29 plus 11, 40. Here we can fit 40 into here. Difference between 18 and 40 is 22. 22 plus 25 is 47. But it didn't check, it didn't do this one. you see, it reached 40, but didn't do this. Wonder why. 1, 2, 3. 0, 1, 2, 3. Weird. Let's arrange that pretty print at each stage, just to, again. So I went from 14 and went to 40, and then, oh yeah, easily could have reached this one, but it didn't. 40 fits, right? Fits into the 18 with length 70, but it didn't get mapped. Getting mapped. Or is it and not doing it correctly? Which one? Getting mapped? No, 40 does not get mapped. So actually, I'm gonna add a test for this. Other range equals, because this is really weird. So the range was started at 18, at destination start of 25, and length of 70. Try expect other range dot fits 40. I bet this passes. This passes. Yeah. I had a start of 18, destination start 25, length 70. So we have 40, value 40. It tries that. That's like really bizarre. Trying to fit. So oh, B probably stands for binary, so I don't want to do that. Range dot fits inputs. Not input. Mapped value. God, I'm very silly. Mapped value, mapped value, mapped value. Let's just make sure inputs, yeah, it's only referred to there. Alright. Not test, although, yeah, not a bad way of running things. Alright, so the 14 gets mapped to 46. 14. 46. 46 not right. Should be 43. But let's again print a value at each stage. I feel like we're not far. Quite like the way we've done the day today. So it goes 14, 14. 14, 14. 53 should be next. 53 is not next. So 14, 14. And it says 14 should go soil 14 and then fertilizer 53. So it fits into this bottom one, 14. 14, so 15. No, that's... Maybe I'm misunderstanding what the problem is asking. Find the lowest location number. That's strange as to... So 14 goes 14 soil and then fertilizer. Yeah, 14 goes 14 doesn't start here. And then... See, that's really weird. That's really strange. So let's... I think maybe we're misunderstanding this then. The first line has destination range start 50, a source range start of 98, range length of that. Okay. second line means that the source range starts at 50 and contains 48 values. This corresponds to that. Whoa. Wait. The first line has destination range. Oh wait, did I get these the wrong way around? Yeah, look. Destination range of 50 and the source range start of 98. This line means that the source range starts at 98 and contains two values. The destination range is the same. It's just the other way around. The very first is destination, the second one is not. So, wow, that's annoying. Destination starts, source start. That's really annoying, actually. 43, is 43 right? For 14? Yeah. Wow, that's tricky. But yeah, glad we did that, I suppose. So the lowest location number is 35. So now what we have to do is var lowest usize equals 99999. No, u32, right? u32. So for seed, if var location equals traverse maps, it's going to take maps and seed. If location is smaller than lowest, then lowest is equal to location. And we're going to print part 1 lowest. And we're gonna just get rid of that comment. Oh god, come on. Yeah. 35. Okay. Integer overflow. Yeah, these are quite big. Max number u32 can take. Yeah, I think we probably overshoot that. And so usize will actually come in. So usize. You need to go usize. Usize. Yep. I think that's all good. Replaced all of those. U32 found usize. Where is this? Self.destination. Oh yeah. Here. Usize. Okay. Yeah. That looks right. That's not the right answer. Okay. That's not the right answer. If location is smaller than lowest, then lowest equals location, and we print the lowest. Yeah, these are big numbers, very big numbers. Maybe that little hack I did with this, no, less than 0, so 0 is included. Let's just do a check here. So it's 21 seed to soil. So I'm going to print seed to soil length. All right. 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, that's right. Yeah, that's right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we don't need to doubt our passing skills, I think. That's really weird. This is like, I was quite confident about that. So it's a little annoying. Quite annoying. Is 35 is the correct answer here, right? Okay. I'm gonna print mapped value. I wonder if there is like some overlap that that I'm not really looking at. I'm going to comment this out for now. Oh, I can't in Zig. No multi-line comments. What I'm going to do is I'm going to print no, I'm just going to do traverse maps, and the seed. Let's do 79. Oh, yeah, it doesn't like that, does it? Because it's a comp time integer. Can you... What? Oh, use as ignored. Yeah. Let's put it into nothing. Okay. It mapped 79. Let's make this big. Let's make this to the side. A little bit. Okay. Like this. Okay. 79, 81, 81, 81, 74, 74, 78. See, oh, it skips. So it went this. Whoa. Also, mapped value. Yeah, there's a big skip there. Map value is done here, so it should start 79, 81, 81. Did we? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oh, what? Seed to soil, soil to fur to water, water to light. Ah, light to temp. Temp to humid. Right. And this was taken 7. Yeah, 7. Well, makes sense now. 78 and 78 is correct. No, 78 is not correct because 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it went 79, 81, 81, 79, 81, 81, 81, 74, 74, 78, 78. It didn't do the location at the end. 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6. So it seems to not have done that very last one. It didn't do that very last one. Print map size. Yeah, I think this is going to be like something really small, but annoying. Map size 2. Range.prettyprint, I guess, as well. Mask for edit. 78, 78, 70. Wait. Yeah, oh, definitely. Look at that's very last one. We have map size 2. We've started 56. Those overlaps. Yeah, look, there's the overlaps that I talked about. The overlaps. Yeah, because this can take, what was it? The source start. No, it can, what the hell, it cannot take. So 56 is the source start and that's the destination. So starts at 56, has that length, and then let's also print this then. Test. Whoa, what's going on here? Oh, missing bracket. At the very end, we have 82. What? Whoa. Yeah, 82 is right. Oh, because the mapped value. Oh god, that's stupid, isn't it? Yeah, the map value doesn't. We don't print that. Oh wait, oh yeah, we don't print that. That's very weird. Okay. 35. Let's actually print location, start, and then location, just to see if there are any anomalies. Seed and location. Nope. Wait, was that maybe it? I think that might have been it, yeah. Well, we missed out like a whole thing. Alright, yeah, there we go, we were fine. Alright, never forget your relay links. And, alright, I did see on Reddit that people were burning their computers and leaving this on all day, so I do wonder what's going on. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like seeds line actually describes ranges of seed numbers. Okay. So the clever way is to kind of compute a range like directly. That's the clever thing to do, to map. I'm going to stop and I'm going to go have dinner, but I want to attempt the clever way. And the clever way I want to show you on Scalidraw. Bear with. The clever way. I think we're, how long? Must be an hour into this. We have time. We have time for the clever way. We have time. Oh, come on. I'm trying to plug a USB in. Great, there we go. Ignore all that. So, the clever way is to no, oh, but what about values that never mind. Well, we'll try it the brute force way, and I'm gonna read the puzzle before I go off to dinner. Let's see, what do we have here? The value of the initial seed line contains within each pair the first value of the start. So within each pair, so that the start of the range of the range, and the second value is the length of the range. So 79, 14. This line describes two ranges of seed numbers to be planted in the garden. First range starts with seed number 79 and contains 14. Yeah, I can definitely see where it's going. Because, yeah. That's really interesting. I think there's a clever way of doing this. I'll think about it. Second range starts with seed number. Yep. Now, rather than considering 4 seed numbers, you need to consider 27. Yeah, and this would be like a few billion. Oh, that's interesting. So we need to take the pairs, pair. Oh my god, like look at these numbers. They are huge. Billions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Trillions of numbers. Oh, yeah. That's not gonna work. No. Alright, I am gonna go have dinner, but I'll finish this, well, literally instantly for you. Be right back. Right, we're back. And we finished off by having done part 1 and kind of being faced with a conundrum in some sort of range splitting. Like, right, we would need to map some ranges. So 1479, we take that range and we, instead of mapping normal numbers, we have to take the range and map the range. Oh, just thinking about how you would even, because right, this is very much an Excalibur type thing, but before spending an hour trying to implement that, I want to try one brute force method, which is to invert this. Right, instead of going from seed to location, we're going to count upwards from the bottom. So the bottom being 0, right? And we're going to see if there is a seed in the range, right? That's the brute force method I'm actually going to try. That seems like kind of a better brute force than literally taking all the input ranges and traversing through all of them. That just seems like so much work. But first, anyways, we need to take the seeds and we need to turn them into ranges. Right, so they said here, right, the first value is the start and the second value is the length of the range. Okay, so var ranges, which is an array of, oh no, we probably don't need that, right? Yeah, no, this is fine. Let's revert these, and let's just make sure that we have the example. Yeah, what I'm going to do is I'm going to basically reverse all of these to be location to humidity, blah blah blah, all the way. Going to reverse every single one of them. Yep, and the way I'm going to do that is if you have a range, let's say 10 and 5. Oh, what was it? Let's actually take an example from here. So the start was 98, and it goes on for 2. And this maps to 50, and also 99 maps to 51. So what you're going to do is you're going to take the destination, in this case 50, and well, you're going to map it in reverse, right? You're going to go 98. So I think to do that, I will just make a change to my parse range function here. And all I'll do is just add a, I'll add a boolean reverse bool. So if reverse, I am going to say source start is equal to destination start, and destination start is equal to source start. So that's, yeah, there we go. So now, now we actually do this in reverse. Okay, and there's quite a quick way for us to test that. Let's do a false here. There's a quick way for us to test that because we can look for the lowest seed. Where we do lowest seed equals seed. Print part 1, and the seed that gave us that is this. Alright, so zig from source seed, lowest seed. It was seed 13. So what we need to do is get the reverse of these. Yeah. So I'm just going to make another bunch of these. There we are. And it's going to start with location to humid. Yeah, location to humid. Humid to temp. Temp to light. Light to water. Water to fert. Fert to soil. Soil to seed. And what I'm going to do is take this and need to defer. Defer. And also dot the init like this. And I'm going to do var reverse maps is equal to 7 pointers to array lists of range. It's going to be location to humid, humid to temp, temp to light, light to water, water to fert, fert to soil, soil to seed. Let's just make sure we have that right. All right, so we have location to humid. Yep. Location to humid, soil to fert. No, not there. Oh wait, where'd that go? Oh, yeah. Yep. 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 Okay, that seems all good. So what I'm gonna do is I'm gonna say reverse range equals try parse range line, and I do want you to reverse it. And at each stage here, I'm gonna do kind of the opposite. I'm gonna do the location to humid. Oh wait, no. We want to do the same, but just we want to do soil seed to soil, soil to seed even. Fert to soil. water to fert, light to water, temp to light, humid to temp, and finally location to humid. And here reverse range, reverse range, go down, and let's do that 6 times. There we go. And what I do want to do is print reverse search. Reverse search. We're going to do traverse maps, and this is going to be reverse reserve maps, reverse maps. Let's go ahead and change that. Reverse maps. And we are looking for the lowest seed. Now we're looking for the lowest that should give us, wait, did that do what I wanted to do? Yeah, I put in 35. Yep, I put in 35 and I got 13. No, sorry, what? No, I'm just confused. I put in the lowest, it gives me the lowest. No, I'm putting in 35 and 13. Yeah, no, that's working. God, I just confused myself so much there. There we are. We don't need lowest seed. I'm gonna comment it out just in case. Just in case I need it for later. What I do want is to take the ranges yeah, so we're gonna have var part2 use size is 0 while true, because we're gonna break out of it. Print parts2. Yep. Okay, parts2. What I want to do is I want to basically see if this exists. Yeah, this is probably going to take a while to finish. Var seed equals traverse maps. This is going to be our reverse maps, and we're going to take in part2. If we're going to say var exists, no, we don't even need that for. Oh, we here we want to go through our seeds, but we want to do it yeah, for 0 dot seeds dot length over 2, so 4 divided by 2 index. Yeah. So if seeds at the index is bigger than or equal to the seed, and seeds at index plus seeds at index plus 1, because that's the range, is smaller than or equal to seed, then break. Outer loop. We can break the outer loop even. I. Maybe we can do I. Right, so seeds I 79. So if it's bigger than or equal to 79, but smaller than 79 plus 14. Okay. And what we're going to do is we're just going to say if part 2 mod 1, let's see 1 million, print counting, part 2, we just want to see if this is going to take forever. Great, I did not increment. I mean, it's not that bad. Okay, it's up to 1 billion. And 2, I bet if this check didn't occur, but might work. Let's just count billions instead. I mean, it still has to perform the operation. Oh wait, why am I? No, this should run instantly. Hold on. This means that part 2 is not behaving very well. Because we shouldn't even get to 1,000, right? Jesus. If we get to 1,000, we will break we'll break. Yeah. Print seed. No, it shouldn't even get to 100. Well, let's start you at 1. That'll cheat, but okay. So it goes. Remember, part 1. Let's keep that lowest seed then. Lowest seed is 13. So we need more info. Testing. Not you. Part 2. So the point is, it should get to 13 and reach 38. So something tells me that my test here must be somewhat wrong. Right, when we traverse, we put in 13. How? What? I swear that I tested this before. Right, if I did print reverse search, did I not do this just now? I swear I just did this. Reverse maps, and I put in 13 or lowest seed. If I put in the lowest seed, which is 13, I should get 35. And I get 38. Okay, so that tells me that something is wrong. I got 38. And then why? Reverse maps, it definitely goes 13. Wait, wasn't this working just like a second ago? Yeah. Soil to seed, fert to soil, water to fertilize, yep, temp. Why am I struggling? This is This is not the part I'm meant to be struggling in. These all good? Yeah, I mean, they look fine. Did I misunderstand how going backwards works? I bet I did in some silly way. Alright, let's do some maths again. So normally this would mean that 98 gets mapped into 50, and that 99 gets mapped to 51. No. Pretty sure that that's all good. Oh god, I hate this type of mistake. It's just is there somewhere. You know it is. Alright, let's just run through this. Let's get rid of you. Actually, we can comment this out, maybe, just for now. We want to do traverse maps with the regular maps and 35, which was the answer, right? Okay. Value of type E size ignored. Part 1, E size just 35. Seed, which was 13. We take out the seed, and we take part 1, and we do that. Oh god, what is it? What do you mean? Oh god, yes. Forget about that. So, wait. The answer for the example is 35. So the lowest location number in this example is 35. And that happens at 13. Nothing else will fine. What am I actually worried about right now? Because I don't... Because something is wrong here and I'm kind of being silly. So I am testing dot 2. Oh, 35 is what I should be looking for, and I got 13. Yep, okay. So what should I look for? Yeah, that was all fine, I just... God. Okay. Now, rather than considering 4 seed numbers, you need to consider 27. In the above example, the lowest location number can be obtained from seed number 82. I think, yeah, reading these like this is a bit weird. I need to know if it exists, yeah? Like, I need to see if any of them eventually exist, right? So the first one showed me too hard, 79. When does it hit 79? Doesn't. And then it starts there, right? So 79 for 14, so 82, 46 is fine. Yeah, that's all fine. I'm gonna really understand because my brain is fried now. Lower bounds seeds I, upper bounds lower bound 79, upper bound 93. Surely I am here? Question mark, question mark. So if that all seems fine, why am I not? What? I'm never hitting it. That's so strange. Man, I'm print seed. Yep. So when we say testing 46 here, we get seed 82 with one of the low bounds. So, oh my god, I am actually stupid. The seed is bigger and then the seed is smaller. Yeah, of course it's one of these dumb things, man. So this part 2 gives you, wait, excuse me, what? I mean, okay, but like now that's too much. It tests 1, seed 26. Damn, I cannot code today. It is just... Okay, but now I've definitely got something wrong here, right? So seed is bigger and seed is smaller. Yeah, no, I'm definitely off. Definitely very off today. We test 19. Oh, needs to be exclusive, right? Needs to be exclusive. Ooh, which way does it need to be exclusive though? I think it's that, the upper bound. And this is definitely, it has to be bigger than the seed. What am I saying? Seed is bigger than or equal to. Seed is bigger than or equal to. Seed I. Oh my god, man. This is just not okay. The seed is bigger than or equal to the lower bound, and it is smaller than the upper bound. Come on, it's taking so long for my brain to just function. Oh wait. Oh, in a way that is correct actually, because it goes to 14. Yeah. No, it's this. I'm gonna control I manually. While I is smaller than whilst I is smaller than seeds dot length over 2. I plus or equal 2, because we want to do that step in 2s. Lower bound, upper bound, and I think you need to be smaller than or equal to, because we should be testing 2, 1, 2, 1, 2. Yep. And the answer is 46. Now we get the correct answer. Okay. Now, every 10 million, we don't break, we print counting parts 2. And that's all good. But now we have to wait. Okay, 1 billion gone. 2 billion. 3. Oh no, not billion. This is going 30 million gone. 40 million gone. 50 million. Oh, that was new. Okay. All right, so less than a minute brute force. That was rather quick. So I'll learn about splitting ranges next time. Actually, I really wanted to finish it because I really want to look through the subreddit and just look at what people did for how they split the ranges, because I can think of like an infinite edge cases right now, and yeah, I really want to know. But cool. It was a fun day. The reverse search I think saved me probably like an hour in just brute force, because that would have been horrible, wouldn't it? Yeah. Okay, really want to go through the subreddit now. So I saw all the memes. They're hilarious. I saw some people's range splitting, like this guy obviously split every range, and it just looks like the correct thing to do, right? So I just want to know how they did it. Go look through some source code. Yeah, this is me right now. Actually, I feel like this. Like, my God, the difficulty this year. Anyways, thanks so much for watching. I'll see you tomorrow.